Hi, Nick here. Good to see you. Now, the last few videos that I've made, I've been very focused on particular parts of projects, filters, and the rest of it. This one's going to be different because this is really a kind of catch-up video on what I've been doing from a kind of broader perspective. So I've just finished my latest transceiver, SSB transceiver. So I've built it. I've tested it, I've used it, I'm pleased with it. I'm about to pull it all apart and put it into an enclosure. But before I do that, I thought I'd show you what I've been building. Because it's a lot easier to point stuff out when it's flat on a desk rather than all kind of shoehorned into a metal can. So this is it. Hope you enjoy.
Right, so the rig is going to go into, guess what? Another bread bin. Yeah, I'm afraid so. Yeah, red one this time. It will be cosmetically very similar to this one here. So this is the bread bin 80. That was the second scratch built transceiver that I built. So yeah, and actually, I mean, yeah, all right. They are a bit large, these bread bins. But they're pretty good. I mean, they're steel, thin steel, so they're you know, kind of easy enough to kind of cut through and drill through and generally work with. But thick enough to be solid, give some rigidity to it, and to provide some RF shielding. So and most importantly, for my purposes, they're big. You'll see why that's important. And now. Because this is I can't even get it in one shot. This is the radio, and I'm just going to talk you through it because I'm about to break it up, which is always a scary thing because it works really well, and I've had it working on 80, 40, and 20. And had some good contacts. I've even linked it up with my linear amplifier and worked into South America, and yeah, fantastic. But now has come the time to actually give it a more permanent home. So I'm just going to talk you through and show you what I've got. Right, let's start on the transmit. So now, what I did for the front end on the transmit chain was I bought from a famous auction website a very cheap microphone, condenser microphone here, and these things are incredibly cheap. They come packaged with different names and numbers depending on where you buy, but they're all essentially the same. But it got some very good reviews actually, and people said, and now it's meant to be plugged into a computer or into a phone. It comes with a thing you can do that. So for kind of podcasting, things like that. But actually, it works surprisingly well, and has a much wider frequency range than a lot of the other microphones I've used. So the sound quality, I suppose, of the of your voice just sounds a lot better. Now, obviously, there's no PTT, so I had to create that. So essentially, I put another little box here, and this little silver tin here is just that. So it has the mic audio going in, and obviously it needs 5 volts to bias the electret in the microphone. And then that little switch on top is a PTT, and then the black 3.5mm jack goes out to the audio lead, which comes up here, which comes to here. Now this is the microphone preamp, and what I used, I did use a little. I had to write it down. I keep forgetting what it's called. SM2167. That's this little red board here. You can see the chip on top, and there's a little breakout board. Very, very cheap from the kind of Banggood, AliExpress, etc. And the advantage with this is, and I'm quite capable of building a microphone preamp from discrete components. But why I was attracted to this is that it has some audio compression on it. Not a lot, only a 2-to-1 compression ratio, but enough just to give it a bit more oomph. And again, it works really well. So I've regulated the voltage down. This little a pot here just controls the amount of gain, essentially how much signal's being put through the microphone amplifier, and the compression's fixed. You can hack it and change a few other things if you want. Some people have done that and got higher levels of compression. But I always want to be a bit careful with compression, really, because we've all heard, ridiculously over-compressed signals, and they don't sound great. So, but that 2-to-1 works really well, and that coupled with the cheapy microphone there, produces the best audio I've managed to produce so far in my home brewing experience. So that's good. So that's the mic and the mic amp. Now next to it here is this little board here. This is a little audio oscillator to produce, I think it's about a 900 hertz tuning tone, and that's what the little switch does there. That just basically powers the module on or off. It's permanently connected. I can show you this very easily. Into here. It comes into here where these two jack plugs are going into. This is the balanced modulator on transmit. So it's permanently connected into that, but I power it off, obviously, when I don't need it. And that seems to be the best configuration. Now I know, because I'm using an Arduino Nano here for the VFO and BFO, I could produce a square wave there, and I have done, and there's various. I tried a few things of kind of artificially producing a sine wave, and with a RC filters trying to convert the square wave to a sine wave, etc. But I don't know. It was never as simple and as clean as actually just producing a separate audio oscillator. So that's what I've done. And now when I used a Teensy in my last build, which was an SDR, that produced a wonderful sine wave internally in the software, and so that's what I did and didn't look back. But it's not quite so simple with the Arduino. So that's what I did. Others may do it differently. So we've got that. So that's going, as I've showed you, into the balanced modulator. Now that's being fed. I'll come back to that in a minute. Let's just deal with the Arduino. Now really this is a very analog beast. I've gone the real simple route here, so you can see there's no flash TFT screens, just a very simple 16:2 LCD. It's got the little converter on the back, so it runs on the I2C bus. Here, I can show you this. Stuck now. Wedged in here is the rotary encoder for tuning, and it's got a push button as well, so that will change the tuning increment. And really that's all it does. I'm using, I've put the actual SI5351 module, which I'm using, in metal tin to give it a bit more shielding, and I just put two SMA connectors on for port 0 and port 2, and I didn't even bother with port 1, and for the VFO and BFO, that seems to work very well. And so what are we doing? Oh yes, back to the modulator. Now, as you can see, this is a homebrew diode ring mixer modulator, and what I did is I've got some attenuation on the local oscillator port coming in, which also helps to give it a 50 ohms load as well, so that's always good. What I tend to do is I tend to drive the SI5351 a bit harder and then attenuate it. It gives me an opportunity to pad out the port, and that helps. because these mixers really do like to see a 50 ohm impedance at their ports if they can. We've got here, this is the transmit audio coming through from the mic amp. It's been switched here, and this is the receive audio, which will go through to the audio amplifier stages we'll get to in a minute. And you can see just here, and I took a bit of time and care with this. So these Schottky diodes are matched, so I've got a whole load of them and went through, I set up a little jig and matched them to my best of my ability. These transformers, I wound those as carefully as I can, and in an effort to try and get as a clean a signal as possible, I actually built, this is a diplexer here on the IF port, which essentially means, now I've got an IF of 16 megahertz, which is far from ideal actually, but that's another story. One day I'm going to pick an IF first and then start to build. That would be a real sensible idea. But anyway, so essentially what that means is that it will only really allow a 16 megahertz signal through there. Everything else it will attenuate, but it will ensure that at all times, as far as possible, the port will see a 50 ohms impedance. So that's really very useful indeed. So that comes out around here and comes to, oh yeah, here we are. Now this is the IF section. Now this is a lot of work on it here. I'm just trying to show you. There's even some more little modules down here. So it's about a 1, 2, 3, 4, 5 stage module, all kind of sandwiched on top of each other. The bottom one is a crystal filter, homebrew crystal filter, built kind of following Charlie Morris' ZL2 CTM in his recent videos. So I built a few of these recently. They're cone filters, COHN, which means that essentially you use the same value capacitance rather than measuring all the motional parameters and everything. They're a bit of a kind of well, easier way of doing it. I don't pretend that they're as good perhaps as doing it properly, but seem to work pretty well, I've got to say, and you control the bandwidth by the value of the capacitor that you use, and you use it throughout really. But yeah, that's an interesting one. Now all these IF amps, and there's a fair bit of amplification going here. These I did a separate video on. Now this is the Wes Haywood and Bob Kopsky termination insensitive bidirectional amplifiers. So each bit is, these are just common garden 2N3904 transistors, but 3 of them in each bit. And so you've got, and you'll see there, you know, so in a kind of left to right direction is transmit, and right to left is receive. So yeah, and they work very well. They were a bit fiddly to do because there's an awful lot of parts on there, but they do work well once you get them tweaked, and you can adjust how much gain you want in either direction. It doesn't have to be the same. The only disadvantage, of course, is that it's not easy to do any kind of automatic gain control in here because these are fixed levels. So I didn't bother with an AGC in this, but I decided I wasn't going to bother with AGC anyway this time. So anyway, so that's that. And that works very well. And the great thing about these termination insensitive amplifiers is that you can have an open circuit on one end, and the other end will still see 50 ohms. You know, so I mean, it's really very good, and particularly when you're connecting it to a crystal filter, that's particularly important. So actually, it's not obvious from here, but actually, some of these modules are on one side of the filter, if you imagine the circuit diagram, and some of them are on the other side. Yeah, so you get a bit of gain before and a bit of gain after, irrespective of whether you're going from right to left or left to right. Okay, so then we go. Oh right, yes. So then we go into the second mixer, and so this is very similar. There's another diplexer on here on the IF port. Local oscillator coming in on the left here. Another little pad attenuator, and then the RF coming out. And then the RF comes out to, where's the RF come out to? Oh yes, now I've got it configured at the moment for 80 meters, so it's coming to there, that's a band pass filter for 80 meters, and then it's coming from there into a switching unit, which just switches, because all of these modules are bi-directional. Which is the great strength of this design, but now it stops being bi-directional, so I've kind of switched that out, and we go into the transmit amplifiers, which are here. Now this transceiver, I used a lot of filtering in this, more filtering than I've ever done before, but I have to say it has paid off, because I get an exceptionally clean signal and some great reports on the audio as well. So it actually comes in through a filter first of all, and then there's about, so you've got there's one, two, so I think the first low level amplifier is my adaptation of an Eamon Skelton design. Was he EI9GQ, isn't he? Which yeah, is absolutely brilliant for a small signal RF amplifier. That's the first one. The one underneath, which you can't see very well, has a more higher power, probably just about a high power transistor on there, just one. That is just a bit more beefy really, so that takes the signal, makes it a bit stronger. Can't quite remember where I got that design from now off the top of my head, but that works well. It's not a huge amount of gain, but what I learnt in the doing of this is that balancing the gain through these stages is really important, especially when you're switching from different bands. And finally, which you can't see at all, but you can just see the heatsink down the bottom. Oh, you might be able to see. This is an old kind of CB RF transistor. And it's actually got some active bias so that you don't inadvertently blow it up, which is always useful. And that will put out, well, I think mine puts out just over half a watt, I think, something in that nature, maybe a little bit more. Comes out through another bandpass filter, actually, because I really want to clean this signal up before going into the final amplifier, the power amplifier. Now, I'm really pleased with this because this is another Eamon Skelton design, but modified by somebody else who I confess, I'm sorry, I can't remember now because I've not got the schematics in front of me. Because when Skelton designed it originally, he used a load of kind of nondescript toroids from Maplins when they existed, and of course you can't get hold of any of that stuff anymore. So somebody else rebuilt it using some actual quantifiable and available toroids, which is really useful. So I based it on that. What I also did though is I bought some of these old Pentium CPU coolers. I don't know if you can see that, which on the bottom of the heatsink is this little fan which attaches to it. So they were intended for putting old Pentium chips on in computers. Dirt cheap, I bought them, and they work really well. So I've got that wired into the PTT so that when you key up, the fan comes on as well. Now I have to say, this was probably one of the most complex RF power amps that I've built, but without a doubt it's the best. I mean, hands down. I've used proper RF MOSFETs for the first time. I didn't go the route of the IRF 510s, and the Skelton design uses them, so they're RDF 16 or something like that. So they're very good. So it actually puts out, I get 14 watts on 80 meters. I get 12 watts on 40 meters, and I get about 10 watts on 20 meters, so that's very good. And that then goes into another bandpass filter, which is around the back at the moment, and then finally into the power meter and out. So that's on transmit. On receive, it's just the same in reverse. We come in through the bandpass filter, and then around into the first mixer. Then we come back, then through the IF stages, through the crystal filter, and then into the second mixer, the product detector, and then we take it off here. We go round to the audio amplifier, which is here. Now I'm trying to see. So the actual audio preamp and amp is down the bottom, and I think did I use an LM380? I think. The problem is that this was the first module I built. Seems like a lifetime ago now. And a little preamp chip before it, so that works well. And yes, now this module on top, this is a classic Doug D'Amore, God bless him, S-meter module, and for kind of including when you haven't got an AGC, because most of the time designs for S-meters are incorporated with AGC, but as I wasn't doing that, I just went down this route, and I used the same little insert as I used on the Breadbin 80 for my S-meter. Is it accurate? No, probably not at all. And you can tweak it and get some indication of signal strength, of course. But of course it will vary from band to band, which when I was using the Breadbin 80 wasn't an issue because it was only one band, so I could get it tweaked relatively accurately, to give some indication. But it's very hard to do that without compensating when you move from band to band. But to be honest, it's really just a cosmetic thing. I just like to see some needle bobbing up and down or something happening when you're receiving. But yeah, and then it finally goes out to a speaker now. This is an old speaker from an old 5.1 surround sound system, 4-ohm speaker, which my audio amp is quite capable of driving. I'll probably take it out of that, I will take it out of that box and fit it internally into the lid of the bread bin, I think. So there it is. And the next time you see it, it's going to look a bit different. And hopefully it'll still work.